Today, we'll be discussing the full version of GPT-4 with visual inputs, which was announced earlier this year during the GPT-4 developer live stream on March 14, 2023. Although many of you use ChatGPT, it's important to note that image support was a significant addition. Recently, GPT-4 with images has started to become available to some users on the internet. The user demonstrations so far have been quite impressive. It's worth mentioning that the rollout is happening slowly, but we can expect the full version to become accessible over time. Now let's focus on the specific announcement regarding GPT-4's visual inputs with Bing. It's essential to understand that this is not the same as image creation, where you ask Bing to generate an image for you. Instead, we're referring to something Microsoft introduced within the last 2 weeks to around 2 to 5% of users. Let's explore more examples and see how it works. If you're currently using Bing and want to test if you have this feature, simply open your internet browser, access Bing Chat, and check for a special icon in the text box. If you don't have the icon, it means you don't have access to GPT-4 with visual input. If you do, clicking the button will open a box where you can add an image by uploading it from a device or taking a photo. Many people were unaware of this capability. While we're unsure about the exact rollout plan, it's clear that it's being implemented gradually. Now let's discuss user examples of what can be done with GPT-4's visual input, as most of us don't have access to the software yet. One notable example comes from a Twitter user named Ethan Malik. He used an image from Reddit to test GPT-4's understanding capabilities. The image showed someone trying to solve a computer issue, and Ethan asked a simple question about a cord the person was holding. Bing's response was surprisingly accurate, identifying the cord as a fan connector for a CPU cooler with a Dragon Ball Z sticker on it. This level of detail is impressive and often goes unnoticed. It's fascinating to see what users can achieve with GPT-4 and images. Later in the video, we'll explore more examples. Let's explore some practical uses of GPT-4 with images because there are quite a lot of them. CAPTCHAs are images designed to differentiate between computer programs and humans. They often contain distorted words or shapes that can be challenging for computers to decipher. However, GPT-4 not only recognizes this as a CAPTCHA but also quickly solves it. It describes the image as 2 words written in a black cursive font: overlooks and inquiry. It acknowledges that it's a CAPTCHA test and explains that it cannot assist in solving it, as CAPTCHAs are meant to prevent automated bots from accessing certain websites or services. This example demonstrates that while GPT-4 is impressive, it still has room for improvement. That's likely why it's being gradually rolled out to a small number of instances. These examples showcase the remarkable capabilities of Bing's visual input, some of which were not demonstrated in GPT-4's live stream developer demo. For instance, one user posted an image of a nephron and asked Bing to teach them about it. Bing accurately describes a nephron as the basic filtering unit of the kidney responsible for producing urine. This shows that if you have an image and you're unsure about what it represents, GPT-4 can instantly recognize it and provide a simplified explanation. Another interesting example involves a challenging image. The user asks Bing to provide a detailed explanation of what it is and reasons behind the identification. Bing responds by stating that it appears to be a cross-section of tissue based on the image description and search results. It goes into further detail, mentioning references from similar images on Google. This demonstrates that GPT-4 can provide detailed explanations and insights even for complex images. It's fascinating to see the capabilities of GPT-4 with images and how it can recognize various objects and provide accurate descriptions. However, it's important to note that GPT-4's ability to diagnose diseases or assess health based solely on images is limited. It can suggest possible signs of disease such as inflammation, degeneration, atrophy, hypertrophy, or tumors, but it cannot determine a person's health or disease status with certainty. The applications of GPT-4 with images are going to be amazing. We've already seen what people can do with text, but working with images will take things to a whole new level. Now let's look at another example that's important because it shows a change or difference in GPT-4's response. Keep in mind that GPT-4's image capabilities have been worked on since the developer live stream 3 months ago. Pay attention because this will give us an idea of how GPT-4's image understanding has possibly been adjusted. In this example, someone asks what's funny about an image and wants a detailed description panel by panel. The image shows a VGA connector plugged into a modern device, which is not the intended use. It's pretty clear why it's funny, but GPT-4 doesn't recognize the humor. Instead, it describes what it sees, mentioning a phone and a charging cable plugged into it. It also mentions that the connector looks like it has a surprised expression, which is not the correct interpretation. The actual joke is that VGA connectors are not meant to be used as charging cables but for old-school monitors. There's a difference between GPT-4's current response and its previous response. Before, GPT-4 acknowledged the humor in plugging an outdated VGA connector into a small modern charging port. This was mentioned in the original GPT-4 paper. It's uncertain whether the changes in visual inputs are due to conversational style or being in a creative mode. Overall, GPT-4's panel-by-panel descriptions seem to have the same level of accuracy or even improved accuracy. In another surprising example, a user uploads an image of a bruise on a person's arm and asks for a detailed description and an explanation of the theory behind it. GPT-4 accurately identifies the image as a bruise, which is a skin discoloration caused by a broken blood vessel. It then provides step-by-step instructions on how to reduce swelling, inflammation, and heal the bruise quickly. This demonstrates that GPT-4 has more applications than we might initially think. Let me give you some examples to illustrate the capabilities of GPT-4 with visual input. In one example, there's a photo of a man ironing clothes on an ironing board attached to the roof of a moving taxi. This is unusual and interesting to see how GPT-4's visual input will handle such images when it becomes more widely available. These models are constantly trained and adjusted, so the output might change over time. Another example shows a meme where countries are represented by chicken nuggets on a baking tray. GPT-4 can not only recognize the image as chicken nuggets on a tray, but also understand the humor and jokes associated with it. It combines image recognition with contextual understanding, which is different from early models. Now, the question is whether GPT-4's image capabilities will be rolled out in Bing before they are added to ChatGPT. Currently, ChatGPT already has a user base of 100 million daily users and is growing rapidly. However, they might be testing the image capabilities slowly to address any potential issues before a full-scale release. The rollout strategy and integration with platforms like Discord is still uncertain at this point. To demonstrate the effectiveness of GPT-4's visual input, there's a clip where someone writes down an idea for a website, takes a picture of it, and gives it to GPT-4. Within seconds, GPT-4 is able to code the website based on the hand-drawn mock-up. It shows the potential of using GPT-4 for various applications, but it will take time to make it widely accessible to everyone. Thanks for tuning into our YouTube channel, and remember to subscribe and hit that notification bell for more awesome content.